So it's our great pleasure to have Dr. Victor Anton, founder and CEO of Wildlife.ai, with us today and sharing about using artificial intelligence to accelerate wildlife conservation. Many of us are aware that a lot of species nowadays are being threatened with extinction. Actually, Victor shared with me the number that nearly 1 million species currently threatened with extinction. And he founded Wildlife.ai. This is a nonprofit organization with a passion to help and to bridge the gap between computer science and wildlife conservation worldwide. And when he was working with camera traps during his PhD at Victoria University of Wellington, New Zealand, he already discovered the strengths and limitations of machine learning for conservation. And after that, since then, he has worked with a lot of research institutions, governments, and communities around the world to translate big data into scientific discoveries and better conservation management practices. And through the Koster Seafloor Observatory project, I got to know Victor, and I learned that he had actually even developed some platform himself for citizen science, and also he's expert with organizing citizen science projects on universe for wildlife conservation and for biodiversity relevant scientific research. And the Koster project is also inspired partly by his idea about how citizen science can be leveraged. So I'm very excited that Victor can be with us today. And it's actually already late evening in New Zealand, but to suit our time, he kindly arranged this at 11 a.m. our time so we could join. So thank you, Victor. Please, now the stage is yours. Thank you very much.
Thank you, Jessine. Thank you everyone for joining us on this journey. I will start sharing my presentation, and let me know if it comes. You can see the screen, can you?
Yes.
Awesome. So today I'm going to be talking about how we're using.
But we now can see your image. I mean, your camera.
Oh, you don't need to see me, do you? To find out. I might go ahead without the video because I don't know how to set it up without the video. Anyway, let's see. Should I stop sharing again? I'm trying to set it up. Let's see. So my screen works now. My camera works. Let's try again. Is it coming through?
No, it seems once you start sharing the slides, then your camera automatically turn off. But maybe that's okay if you don't mind.
Okay. Yep, I can talk, narrate it over just audio. So yeah, today I'm talking about how we are using artificial intelligence to accelerate wildlife conservation at Wildlife.ai, and a little bit of an overview of how the presentation is going to roll. I'm going to provide a bit of background about myself and around AI and wildlife conservation, and then describe some of the structure that Wildlife.ai has as an organization, and a couple of projects that we are involved with. So let's start with a bit of an introduction. And a little bit of a warning, I am a terrestrial biologist. My background is in terrestrial ecosystems. So most of you, I guess, I assume, might be marine biologists or have to do something with marine ecosystems. But I am a terrestrial biologist by training. I did my PhD at Victoria University, working with remote cameras to better understand, introduce mammals in urban environments here in New Zealand. So I'm going to start talking about artificial intelligence and about machine learning, and because these terms mean different things for different people, I would like to provide a couple of definitions so that we are on the same page. AI, when I mean AI or artificial intelligence, is the theory and the development of computers to perform tasks that are usually associated with human intelligence. And when I talk about machine learning, it is a subset of AI where we use statistics to teach computers how to learn with data without explicitly telling them what they need to focus on or programming them. And it is not a surprise that artificial intelligence is changing the world as we know it. It has huge impact in a lot of fields, and it's normal to come across some of these graphs highlighting the impact that artificial intelligence can have over other analytical tools. So for this specific graph, it is graph from the McKinsey Global Institute report, and it provides an overview of what is the potential incremental value of using AI on different sectors. And the key message that I see in this report around the impact of artificial intelligence and the benefits of AI is usually that is missing the environment or the sustainability or the ecology, the wildlife conservation sector. And it's that's how like the artificial intelligence kind of world or environment is set up, and that is mostly driven by other sectors. AI is analytical tool, is a way of analyzing data, and I'm going to provide a little bit of overview of how data is currently managed and processed in conservation. So if we think of the life cycle of data, we start with collection, we process it, and we provide some sort of output. The current approach that we follow in conservation is biologists go out onto the field and collect or sample the data in specific locations and at specific times. Then that data is being processed manually and is processed locally on your computer, on someone's computer, and then it provides an output that this tends to be providing insights for a specific project, and it is hard to replicate the process. If we think of the approach of the data lifecycle on a machine learning kind of a system, the collection, it could be done by citizen scientists, they can have access to some of the skills that conservation practitioners have by the use of machine learning, and remote sensing. It could be used to increase the area that is being sampled and the amount of times over time that that can be sampled. And the process of the data is automatized, and most of the times it can be stored and it can be processed on the cloud. And then the output that provides, it can generate insights on a global scale, and it can be easy to reproduce by others. If we look at both approaches, the current approach and the machine learning assisted approach, we wonder why most of the conservation biologists are still using the current approach. And there are three main limitations, three main reasons for the limited use of AI in conservation, and is that most of the projects are community-led or from the bottom up. So when the people start the project, AI is not one of the priorities that you have on the project. There is an overall limited knowledge of what machine learning and AI is, and what it can do and what it can't do. And then there are not enough resources to use this technology for conservation. So along with a couple of colleagues, 2 years ago, we decided to try to create a non-for-profit to overcome some of these challenges and to bridge the gap between AI and conservation. This organization is called Wildlife.ai, and we have three main pillars. One is the conservation, one is the community, and the other one is the education. I'm going to be talking today mostly around the conservation and a little bit of the community, but the education is a crucial pillar to make sure that these skills and these tools are passed on to the next generation and they know how to use it for environmental good. So jumping onto the community pillar, Wildlife.ai, we do have a group of rangers, we call, that there are 5 types of rangers. The first one is data rangers, who are data scientists, and they build the machine learning models and the pipelines, and they work on a mentor-mentee relationship where a more experienced or more senior AI expert partners with early career software engineer or data scientist that wants to have some hands-on experience, and they take one of the tasks for a specific project. So that has been very successful, and yeah, it is great approach, and to see how people start to pass on those skills. And then we have the ecology rangers, who are usually biologists, and their role is to ensure that the models are having the greatest impact for the environment, are making the greatest impact. And then we have project rangers, who are managing the project and who are the glue of the entire project, making sure that everyone works together. We have the community rangers, who make sure that the community is involved at each step of the process. And then we have the product rangers, who are usually UX wizards that make sure that the solution or the product that we are working on, it can be used by others, not just a specific project. So before I jump onto the couple of projects that we're working on, I would like to describe how we engage on a project. So there are three main stages. One, we identify a wildlife conservation challenge, and then we try to create open source and scalable solutions. And through the process, we involve scientists and with the community to make sure that we make the most out of the project. So today, the two projects I'm going to be talking about are above and below the water. The Wētā Watcher is based here in New Zealand, and the Koster Seafloor Observatory is based in Sweden. So I'm going to jump onto the first project, and the conservation challenge here that we are trying to tackle is here in New Zealand. Unfortunately, we have introduced predators who are mammalian predators, so rats and possums that predate on native fauna and native biodiversity. So there is this this project or this push in New Zealand to try to reduce the amount of predators so that hopefully the native biodiversity can thrive. So here on the right, you can see a few examples of some of the biodiversity that you can find in New Zealand, the unique biodiversity, and trying to understand the relationship between the predators and the native species is a challenge. And most of the conservation work goes towards bigger animals and easier to monitor. So that's the case of birds, for example, and usually cold-blooded animals like insects and reptiles are harder to find out how that relationship between the predators and the native biodiversity plays. So with that on mind, we came up with a camera that monitors everything that moves in front of them, independently or their size. So what you see here is a drawing of the camera. So the camera is inside this 3D printed case, and the devices that we use are open source. And this camera is here facing this area, which is a platform where the animals walk by. These three things are plastic barriers that redirect the animals, funnels them to try to maximize the number of times that it gets across the camera. And this is a post just to lift the camera off the ground. So this drawing, actually, it was made by one of our scientists that we work with. There were 30 students from a local school here in Taranaki in New Zealand, who help us test the devices and set them up on the field. And we put them out on areas where there are different numbers of predators. So they help us analyze the information and they share it with the community. So it is about bringing the community on the journey, so that they take ownership of it. So these are prototypes, and these are the initial results that we got from some of the cameras. So again, this is the camera facing down onto this wooden platform. So this is one of the Wētā, one of the largest insects in the world, that is just walking by. That's one of the introduced predators here in New Zealand, a possum. Some rodents showing up and sniffing around. Lizards, we've seen worms. So it does record anything that moves, spiders, and that's a prototype. The global impact that we are trying to achieve with these devices. This is a photo of the actual device. The global impact that we are trying to achieve with this is to come up with a camera that it can be used to monitor multiple species, not only mammals, like the currently available cameras, and a system that it can process the images on the device and only send the information processed, so that you can have timely and accurate information around the health of the ecosystem. And then again, with the approach of involving the community and making it open source, we hope to have a vibrant community of people using this device and adapting it. So that is on one of the projects that we have above the water. The next project is the work that we are doing with the Ocean Data Factory and some of the researchers on the audience. The conservation challenge here is a marine biologist wants to understand what is the health of the ocean. So they use ROVs, or remote operated vehicles, to get a lot of information, to get a lot of videos from the ocean, from different areas of the ocean, and then process them and trying to get any insights on the health of the ecosystems. The challenge is to process all these videos on a timely manner. So the solution that we're working on is the Koster Seafloor Observatory, and we published last year a paper on how the system works. So I'm not going to get into too much detail at this point, but there are three main blocks. One that is around the data management, so that you can go out and collect the information, store it, and process it on an efficient manner. Then there is the citizen science block, where this footage gets analyzed and labeled by citizen scientists. And then there is the machine learning and high performance computing block, where we use the annotations that citizen scientists have provided to train models that then researchers can use to analyze large amounts of footage. The beauty of this process is it is by blocks, so it is modular. People can use it. If you have label information, you can go ahead and only use the machine learning and high performance computer. If you are after getting labeled information, you can use the citizen science block. So it is a modular kind of approach that we followed. And again, involving the community, involving people onto the project is very rewarding, and we believe is the way to go ahead. So we partner with Zooniverse. We created a project in Zooniverse, the Koster Seafloor Observatory, a couple of years ago, and we had over 4,000 users classifying over 100,000 times these videos, and they interact with them, they learn, they ask questions to the researchers, and then their label information, we are using it to develop these models to identify some of the species that the marine biologists are interested in. The models can generate that can go through footage, and then you can start to infer some of the ecological questions that you might be interested in. So this is an example of the research conducted by Joel on the Kosterhavets National Park, where on the left we see the footage collected in 2001, and on the right some footage collected in 2020, and looking at the occurrence of a specific organism inside and outside marine protected environments. The system is modular, so it's open source, it's modular, so other people can use it, and that's exactly what we are doing at the moment. We are collaborating here in New Zealand with the Department of Conservation to use the system and to adapt it onto a different sampling method that they are using, where they are using it to count fish to better understand the health of fish populations. So they drop these cameras inside and outside marine protected environments, and they look at the fish populations. So far, in less than a year, we have also got more than 40,000 classifications and over 2,000 comments. So the people are genuinely interested in helping scientists, and their classifications are accurate for science. The global impact, again, is to have a system where you can monitor marine environments, and you can increase ocean literacy and educate people on how to use digital technologies for marine environments, and improve the ecosystems. Wrapping up the presentation, at Wildlife.ai, we use artificial intelligence to accelerate wildlife conservation, and on the way we aim to achieve 6 of the Sustainable Development Goals, where community-based projects provides opportunities for people to understand artificial intelligence, where we develop innovative uses of AI to better understand the impacts of climate change below and above water, and where we work with as many individuals and organizations as possible. A call to action: how to get involved with Wildlife.ai. Send us a message if you have any idea to start a project. Help us identify some of the species that we have on the citizen scientists, on the citizen science platforms. Donate, support us, or become a ranger. Quick round of acknowledgements for organizations that are supporting us on the way. and time for questions.
Thank you, Victor. Yeah, the projects, they are very interesting. From those in the marine systems to those in the New Zealand, the local systems, different sizes of the species. And we welcome questions.
Just a brief comment. Thank you, Victor. Very interesting. And I think that probably what interests me the most of what you presented is that for AI to work effectively within this project of conservation, but it could be the same in other areas, you need an ecosystem, not just in terms of, environmental ecosystem, but in terms of including many different other entities. You need a community, you mentioned. You need the data, of course, but you need project rangers, community rangers, product rangers. You need so many people involved. So otherwise, AI cannot be used to full potential. And probably, correct me if I'm wrong, but since we are dealing also with issues of engagement or studying more how to promote engagement in Koster, so I think this is one of the. Do you consider the construction of this ecosystem of people participating one of the main challenges, for example, for effectively leverage the potential of AI?
Totally. I think, yeah, as you mentioned, it is not something that artificial intelligence is not something that only software engineers, is a task only for software engineers. There is a lot of different layers to make sure that you can have a successful project. And I think that with any other projects, having a community behind that take ownership of it and that participate on it and have a say on it, it can go a long way. So yeah.
Yeah.
Feel free to directly ask a question, or you can also raise your hand if you. Okay, we go to question in chat. Eva. Eva asked, have you developed or do you use any kind of image recognition application?
Yeah, so we do develop the models to recognize the images. So on the paper that we published last year, we mentioned the models that we use and the applications that we use. But again, it's a modular approach. So we are trying to make it widely available for anyone to use, but they still be able to adapt it to the user's need. Let's see.
We got also another question from Mafalda. Mafalda, do you want to just turn on your mic and ask Victor?
Yeah. I wasn't sure what would be best. The marine project that you presented, where you're identifying species with the recognition, I was wondering how long that's been going on for and what your biggest problem with developing the recognition algorithms are, or if they're still being developed, what the biggest challenge has been.
So the biggest challenge is to try to come up with an algorithm that identify all the organisms that you're interested. So our initial approach is try to focus on key species that it can be that they can be telling you something about the ecosystem health, so that if you come up with an algorithm that is accurate for a single species, and then you can infer the health of the ecosystem from the presence or absence or density of that species, is the way to go at first. But yeah, building up onto having a system that it can identify 20, 100, thousands of species. Scaling up is it is a challenge. That's some of the learnings, I guess. That
how long has it have you guys been working on this project for?
So we've been working for over 2 years now on the project, and it was mostly building the infrastructure so that these models talk to each other, and that you can change whether you can use one server or another server, or machine learning approach or a different machine learning approach, so that is adaptable for that. So trying to have like that adaptable infrastructure, as if you mean, has been kind of like the focus of this initial work. And two and a half years we've been working on the project.
No, well done. Good progress. Thank you very much.
Thank you. So Victoria, I'm also curious that you mentioned something about thinking about the role of AI, or somehow prioritize. Like, do you mean that for such kind of projects, the project managers or the scientists, they need to put AI into the design of the project when they initiate the project?
Yeah, so conservation projects usually comes from community or conservationists, that they identify an issue and they raise the bell and they are like, okay, we need to do something about it. So usually on the toolbox of conservation biologists or the community that are interested in the environment, AI is not often part of that toolbox. So yeah, trying to include it early on, it can help in how to start collecting the data, how to manage the species that you're interested, or the ecosystem that you're interested.
Can I ask one more question? Sorry.
Oh, yeah.
You mentioned a lot about citizen science and involving the community. How easy has it been to involve the local community in these kinds of projects, and how do you organize their involvement? Is there an app that they submit data through? Do they help the scientists go and collect data? How does the citizen science aspect of these projects work?
So it's all different for each project. So the two projects that we mentioned here, for the underwater footage, we already had the footage. So it was about making an easy way for people to access that footage and to have enough information on what they need to do. So those were kind of like the two keys to get their engagement. So on Zooniverse, you don't need to log in or anything like that. With just the link, you can just go ahead and start classifying.
Cool.
So just try to break those barriers as much as possible. If there is any other application or any other organization or place where those volunteers are, just partner with them. You don't need to try to come up with one solution fits all. I think that it really pays off on getting a hand around of what the project is, who is out there doing what, partner with yeah, trying to close the loop. But yeah, it depends on the projects. Like for example, with the Wētā Watcher, the camera, it was around bringing students to actually start with setting up the cameras, go through the footage, learn about it, and yeah, analyze the information, and they even share it on like presentations and with other people. So it's yeah, getting them engaged on different levels, I guess.
No, that's really cool. Again, well done.
Yeah, thank you.
Thank you. And Eva, you asked about the data management aspect. You can also turn on the mic and ask the question.
So yes, I was wondering if you got any data management plan that perhaps you could share. And I'm also interested if you have any data platform, specific data platform that you use.
So we use open source solutions, use Python, we use code to deal with all the processing and all the data management and all the training of the models. But we try to create solutions that it can be used for different platforms. So we don't have, I guess, a specific data platform that we use. There are solutions out there that it can be useful for a specific project, but we don't have a go-to kind of product, I guess, as you mean it.
Okay, thank you.
Victor, so in those citizen science projects, usually there are a lot of people who join and do the classifications. Then maybe the scientists, they also want to ensure the quality of for example, the annotations. So what kind of measures do you usually adopt to ensure the quality of those annotations?
Yeah, that's a good point. So we provide as much information for the citizen scientists to make accurate classifications. So we provide a lot of examples and training. And also we have several citizen scientists looking at the same video, and then we aggregate those classifications. So we have, for example, 8 different citizen scientists looking at one specific video, and if 7 out of the 8 they say that there is a deep water coral, and then we can compare it with a ground truth, and we can say, okay, an agreement of over 90%, it provides the same accuracy as a biologist going through the data. So then on future videos, you can just rely on people and say, if people have an agreement of 80% or 90% or 60%, then it's as accurate as scientists. But you need to have that baseline first to make sure that the citizen scientists are accurate.
Thank you. So both through provide them with training and also through some mechanism design where the same value is classified by multiple citizens, and only if there is a consensus level reached, and then you considered the video as properly classified, annotated.
That's correct.
Thank you.
It's also important to mention that it's not citizen scientists analyzing it or machine learning analyzing it or experts. Like the idea is to have several layers of people analyzing at different points. So then the process of analyzing large amounts of data accurately is shared within machine learning algorithms, the citizen scientist, and finally, if the citizen scientists don't come to an agreement, it will be up to the experts to classify those tricky, I guess, or harder to identify sections.
Thank you. Stephen, yeah, Stephen, you can also turn on the mic and ask if you prefer. Oh, I can read the question. So Stephen asks, is a machine learning assisted also by physical data like light, time, temperature, humidity, etc.?
So at the moment, the approach that we're using with the machine learning, it doesn't include that information, but it can be included, like any other information to facilitate the predictions of the model. So yeah, that's a good point to add metadata, I guess, rather than only the visual information. I think that it will be good to add these different pieces of information that it can help the model to predict accurately.
So basically, this is about like not just the video or the image data, but also data from other sources.
Yeah.
Different data sources can be used simultaneously as input for the development of machine learning program, and that's feasible.
That's correct, yeah.
So I'm curious now with those data, the training data like annotated by many citizen scientists, then in the model development, have you encountered any challenge or problem, or are you satisfied with the algorithm being developed?
So it's important also to highlight that artificial intelligence or machine learning is one tool. So it has, as with any other tool, its advantages and disadvantages. So for the purposes that we are working on, we are really happy with the results, and it works for again, like trying to focus on one species. That it might be an ecosystem engineer that it might tell you about the bigger picture. So for those kind of case studies, it has worked quite well. So yeah, I guess there's a lot of room for improvement, but I think that it was the right tool for the right job.
Thank you.
Victor, sorry, one last question. Are you guys mostly focused on developing the data management and processing side of it, or do you also design and build all the equipment they use to collect the data? So, for example, the image gate things that the animals walk through and the submersible and things, or are you collaborating with other companies for those data collection methods?
So for the Wētā Watcher, the camera, we are developing the camera because currently available cameras don't work for that purpose. So we look at what is available, and if those tools are not available, or they are usually expensive or not accessible for everyone, we have access to like engineers that can help to develop these resources.
Amazing.
So yeah, we are developing our camera, and the idea is to try to make it available for more people to try to use it on their
Yeah, so for example, in outside of New Zealand, people could also use your equipment to collect more data from different areas potentially.
That's right.
Yeah, nice, great, thank you.
And just a follow-up on Mafalda's question, then that suggests maybe your the devices you're developing, is that are you thinking about some open source platform, and then people can just build on that and they can easily like assemble devices themselves, just following the protocols? Okay.
That's right. Yep. So we are taking that approach, but also are aware of the limited skills that some users might have. So we are looking at trying to partner with organizations that can assemble the devices, and they can ship it to wherever the users are. So making it easier for the people to use it rather than trying to put the whole camera together. But yeah, providing those two options, or buying it or purchasing the actual like entire camera build, or making it your own, following the instructions.
Thank you. Any other questions, comments? Is there some friends who are new to this ocean data webinar series? Or maybe some of you are thinking about wildlife conservation projects, leveraging AI or citizen science? No. So if you are not on our email list, you can put your email into the chat, and I can also add you to the email list. And you are also welcome to check this web page and to get to know more about our seminar series. Yeah. Okay. So Victor, maybe one last question that I have is, if you give some suggestions or recommendations to people who are thinking about starting similar projects as you did, what would you recommend them from the very beginning of the project?
I guess that having a well-defined question, and then checking whether AI is the right tool for it. Because sometimes people want to use AI for some of the work that they are doing, but it's harder to narrow down the specific questions that they are trying to answer, or how they can make the most out of AI. So I think that having a specific question and having a well designed kind of like approach, and yeah, I think that goes a long way, because if you start trialing it and using it, you can get on a rabbit hole quite easily, and then after, I don't know, a few months or a few days or a few hours, you realize that, well, actually it's not the right tool. So yeah, having a good design and a well thought approach, I think that it goes a long way.
Thank you very much.
Thank you. Thank you everyone for listening. Yeah, feel free to get in touch.
Thank you, Victor. Thank you, Yishin. Great seminar.
Yes.
Thank you.
And in March, we will have Matthias Obst sharing with us about the Swedish biodiversity data infrastructure. And so now we see, okay, AI, but then another very important dimension aspect is data. Good data, high quality data. Thank you so much.
Thank you. Bye.
Thank you.
Take care. Take care, everyone. Bye.
So